Hi everyone, welcome to chapter 5. This is the first activity. So basically we are gonna read an image and store it on a ND array on the NumPy using the imRead function. Then we're gonna show the dimensions, the shape, the size, the type and the bytes of each image. The first one is gonna be with no color and the second one is going to be with color. And it's going to be the same path. So let's run the program. Okay, so it's now running, and here you can see that the output is NumPy ND array, which confirms that the image has been saved on a ND array. And here it says the type, the dimension. It's a 2, then here is a 3. Then it shows the shape, then the size, then the type, and finally the bytes for each of the cases. Welcome to activity 3, chapter 5. Now we're gonna do basic operation on images. So then again, we're importing CV2, and then we're using the same image as the previous activity, and we're just printing down the image 10 by 10 and image 10, 10, 0. So I'm going to run the activity, and here it goes, and it's going to show the result. So in the first case is 103, 110, and 130, and in the last is 103. Hey, hi, how you doing? Welcome back. In today's video I'm going to show you how to split the image using the import of the CV2. So we are gonna split the RGB into 3, and then we're gonna merge it, and we're gonna visualize it using the function imShow with the merge image. So let's run the program. Run model, and that's the image that is merged. Hi guys, so now we're in the next activity on the same chapter. We are now adding border to the image. We are changing the image to a smaller one so it can be easily spotted. So this is how we can make a border. We are just making these adjustments here. In the P1 we are making it so that it has the values of 10, 10, 10, 10 border grab. The same goes for the B2, but we're adding here the value of 255, 0, and 0, and then we're showing the grab and the constant. And we can destroy the image by using the Windows function. So I'm going to run the program. Okay, it's now running, and as you can see the border is on the image. So now we are doing arithmetic operation on images. So we are using a 1920 by 1080. Those two images have the same dimensions. So here we are using addition, and you are gonna see what happens when I run the program. So let's do that. And as you can see, the images are splitting together, are merging into this abomination. So now we're doing the same, but instead of using addition, we're now using subtraction. So it's gonna be the inverse of the last video. So I'm just going to run it. And there you go. That's what happens. Hey everyone, so now we're doing blending and transition on images. So firstly, here's the blending. So right now we are just adding imshow blended image. So cv2.add weighted image 1 0.5 image 2 0.5 0. So what it's gonna do is gonna blend the both of the images into one, and we're gonna run the program so you can see for yourselves. So that's the image blend together. So hi everyone, so now we're doing a transition effect. So we're using the same images as the previous videos, and we're just adding a cycle for here. So I'm going to run the program, as you can see, so you can see how it's. We're doing the transition effect using push buttons, and they're connected to the pin 7 and 11, and we are making the GND common for both of them. And this is the code here. We are using a cat image and a wolf image. Both of them have the same dimensions. And there is the setup for the buttons. That's a 7 and 11. And we are using if to detect if whether the button is pushed down or not, and what of the buttons is turned on. And this is the run. So I'm going to click on the left button, and you will see how it will make the transition to the cat. There you go. Now I'm going to click on the second button, and it's going to turn back to the wolf, just like that. And that's everything. Hi everyone, so now we're multiplying images by a constant and from one to another. So the exact part of the code that does that is the part that says cv2.imshow image1 by 2. So basically what happens there is that it's going to multiply each one of the images and then by 2. So I'm going to run the program, run model, and you will see that it looks quite awesome. There you go. Hi everyone, so now we're doing negative on an image. So we're subtracting all the color from an image and we are gonna inverse it. So this is the code. We are importing CV2, image CV2 and read, so that's the path of the image. We're putting a 0 there, so that it has color. Negative equal ABS, 255 minus image. Then we are putting CV2 imshow grayscale, the same but in negative, and it's going to wait key, and if we press the Windows it's going to destroy it. So I'm going to run the program, run model, and you will see the same image but in negative. Here's the negative image and here's the original image. So there you go. See you guys in the next one. Everyone, now we are doing bitwise logical operation on images. So the OpenCV library has many functions for computing bitwise logical operation on images. We can compute bitwise logical AND or XOR and NOT. The best way to demonstrate this is running this program. So we're importing CV2, importing NumPy, matplotlib, and we're doing for the first image an NP array. For the second, we're putting np.transpose image1, and this is for the NOT, this is for the AND, or an XOR. Those are the titles for each one of them. and this is the arrays for the images, and we are putting a for to do the subplot of the images so they can be organized once we run the program. So I'm going to run the program, run model, and those are the images. So here's the image 1, 2, this is the NOT, and or an XOR. Thank you so much for watching this.